Hey yeah everybody, Joe here. I want to check out a puzzle today by Olof Helleblad Johnson. It is called Disco Floor. The rules are normal Sudoku rules apply. That is 1 to 9 in every row, column, and 3 by 3 box. Each line has a unique non-negative number associated with it. This number indicates the difference between adjacent digits along that line. Number indicates the difference adjacent digits. How many lines do we have then? We have one, two, three, 4, 5, 6, 7, 8, 9. So we can't have nine be one of the possibilities because we cannot put a 0 or a 10 into the puzzle. So one of these lines has to be a difference of 0, which one of these lines has to be the same number, and that would be this one. This is the only one that can be a difference of 0. So these will all be the same. And then pink will be over here somewhere. So 8 will also be 1. And 7, obviously. What about this one? This one will have to be a difference of 1. So it's going to be a Rinban, more or less, as it will be a, oh, between adjacent digits too, though. So it's going to count. Well, okay, it's 6 digits long, so 4, 5, and 6 will have to be somewhere along here as well. Four, 5, and 6 will be there somewhere. Two, 4, 6, 8. This one can be 2. Which one can be 8? Every other number's 4 could be 1, 5, 9 though. So 4 could be a 3. 5 could not though. 8, 7, 6, and 5 are going to be quite difficult. However, this one, these 2 digits could be the same. These 2 digits could be the same. Is that true for 8? Yes. But this one, this one, this one, this one can't be 8, 7, 6, or 5 either. this little sideways J here. So 8, 7, 6, 5 are these 4. 8, 7, 6, 5. This one is 1. So these are going to be 2, 3, and 4. This top one cannot be 4. Could it be? It can't be 3 either. Oh, that's not right, is it? 2. This one can't be a difference of 2. This one has to be the 0. Oh, this can be a difference of 2. But this one has to be the difference of 2. And they are all odd numbers. And then these will be 2, 4, 6, 8. So that one is 2, that one is 1. These are 3 and 4. If this one is 4, it has to be 1, 5, 9. And then it would go back down or up the other way. But okay. So this one cannot be 8. So 8 is now this one, or this one. That one could be 7 though. Eight, 1, or 2, 9 would be the only possibilities for 7. If it was 5, it would have to be 4, 9. If a 9 went there, it'd probably be okay. If this one is 4, then it's 1, 5, 9. Would that be okay? Suppose it would. 1, 5, 9 either goes here or here, which means this cannot be 1, 5, or 9. Um, also, maybe not also. Well, this can have a 6, or wait, it could have a 6 on it, actually. Could be 369. If it was 4, it could not. It can be, what can this be? It can be 1, 4, it's going to be a modular numbers. It's going to be 147, 258, or 369. It's interesting. There seems to be a lot of things at play in this one. We got odds and evens started. We got modular started. Might even have an entropy started. These are kind of like German whispers now. Or well, no, maybe not. Well, yeah, they are, I guess. Because none of them, they do have to be 5, 6, 7, or 8. So yeah, that is true. So neither one of these will have 5 on it. If that means anything. This one, though, could, if it was 159. Um, 6 is up here, though. Let's start with that. So it is down here. So if it was on the green line, it would have to be 3 or 4. So it can't be there. If it was here, these would be 3, 9. But it could quite easily just go there. And these could be something else. Oh, also, these are only the modular if the difference on this line is 3. Obviously, if this is a difference of 4, it's 159. However, one of these are 159. Would that work with all these odds up here at the top? 1, 5, 9, 5. I guess either way, those are the same digit. These could be the same, but those could be the same as well. So if this is 6, then that would be a 6 as well. A 6 cannot go here. Oh no, it could if it was a 6, 1. Which ones can be 8? This one cannot. This one can. This one can. And this one still can. 7. This one can even be a difference of 5, but only if that is 9. Do, 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 do. What about... Oh, I don't know. If this is 159, that would have to be... There would have to be a difference here. Could be 2, 7 or something. Maybe I should mark evens. I do have 3 evens in this box. Can this one be the difference of 6? It would have to be the 2, 8, making that a 4. If this has a difference of 4, then these two will be all the odds. And this will be 2, 4, 8. Is that going to do anything? I think it would probably still be okay though. If this was 2, 4, 8, like that. This one of those, one of those. These two, the other, no, one would be the 6. The other one would be down here somewhere. And this one, the one in the corner, would be down there as well. So I think these 5 would be odd in that case, which I think would also be fine. These two would be odd. Do anything else with 6. If this one had a difference of 3, it could be on there. Let's see, where was I at? This one and this one was a difference of 3 and 4. 1, 5, 9, 5, 1 or 9, 5, 1, 5, 1 or 9. Those two would be 5. If this was a difference of 3, it would be a modular set. And then this one would be 159. But either way around, I think is fine. Um, Let me just mark this. If this was 7, that could be 1 or 9. If it was 6, it could be 2 or 8. If it was 5, it could be 3, 7, or 9. So basically about anything except for 6. It can never be 4 or 5. Oh, this is also going to... This one has to be 5. I should have got that right away. I think I was treating it like a rin band. But this one can't be 1. This one can't be 1. Can't be 9. Can't be 9. This one will be 1 or 9. And this one will be 1 or 9. So this one cannot be the 4. Difference of 4 line. This one has to be difference of 3. And this one now has to be 159. In some order. So now, this one, it could still be No, this cannot be a difference of 8. It cannot be a difference of 7. It can be a difference of 6 or 5. This one cannot be 5 anymore. So that 4 cannot be there because it would have had to be 5. This one could have never been 8. It cannot be 7. It can still be 6 or it can be 5. Six. This one cannot be 8 anymore either. So this one is 8, which is going to make these two the same. And it will make these two the same. If that is pink, pink would go here. It could be pink. Maybe not. This was unable to be. This is 5 or 6, was that right? And that is 5 or 6. Yeah, that one cannot be 7. This one cannot be 7. So this one has to be 7. That could be with 1, 8. Or 2, 9. So this is a 1 or 9. And this is a 7 or 8. Not a 7. Two, 8. Okay, so this 1, 9 is going over here. It can't be pink. So it has to go there. Do I know that none of these are 1, 9? Well, no, they have to be 1, 9. Isn't that right? Let me check out blue here. These have a difference of 8. They must be 1, 9. Alright, so we can map some 1, 9s around. I think maybe I will do that. And check out all these other colors at the moment Take those out, take those out, those out, those out. So this cannot be 9. So this, could be 3. 6, 9, that could be 6, and that could be a 1 or 9. It would be a yellow. That would probably be okay though. Perhaps yellow is going here. Pink. It could go down. It could be on this line as well. Pink is going in one of those. Yellow on this side. One of those. This cannot be 1, 9, 4, 5, 6. It could be 2, 3, 7, or 8. Okay, that's fine. I do have 5 down here though. And it can't be on here, because this would have to bring it here. So this one is 5. 5 will be down here and over here. 6 is now there. And if it goes on here, I can't go on here, because this is a difference of 5 or 6. And it cannot be 6, 1, and we cannot have an 11. So that will be 6. Now this is probably getting more scrunched up. Well, no, it's still 2, 3, 7, or 8. Can 4 be on here? No, it cannot. So 4 is in none of these. 4 is either here or here. If this was... This has a low and a high on it. That's all I can say, I guess. 2, 3, 4, 7, 8. Yeah, that's all that's left. Alright. So this has a difference of 3. And whichever way it goes, if I do anything with this, maybe not quite. Pink does go down here. And if the 6 went here, and pink went on here, Pink cannot go here. Because it would be starting here, going either down or up, and then it would have to turn around and go right back the other way, and it would have to be itself again. Or not itself, but it would have to be this first number. So if this was pink, it would be broken. Because these two digits would have to be the same. So if pink was here, it would have to be 9, 6, 3. But if this is 6, then pink has to go here. And then it would have to be 1. Then it could be 4, 7. Or maybe I should say, what if this is pink? If this is pink, then that has to be 6. This would be yellow. And that would be 3. So is this 1, 9? Because if this is 6, that could not be 3. Because that would be 1 or 9, and they're both in the column. So it would have to be 9, which would be either yellow or pink. If this was 6, then this would be pink. So this is 1, 9. Pink and yellow cannot be down here. Although yellow could be in this row. That is fine. Yellow would be there. If this is... Oh yeah, because that could still be 4. So this can be 4, 7, 4, 1, or 7. Or it can be 9, 6, 3, 6, 3, or 9. Oh, that's not confusing. Okay. So, does pink go on here? I guess pink could even go there. Or, well, I guess what I was looking at is if pink goes in one of these two, then it would have to go here. I guess that would be okay to be yellow as well, though. Yeah, I think it would be okay. Oh, this cannot. Uh, okay, it would still be okay. Can this be five? Or no, not five, but I don't think this. Oh yeah, it could be 4, 5, 6. I guess that's okay. I need to kind of ignore this at the moment. That's confusing me. It just looks weird because not all the numbers are there. So this was a difference of 5 or 6. And it was 8, 2, 2, 3, 7, 8. If this is pink, then pink must go there. Oh, and pink cannot go there because it would be on an extreme end. As in, it needs to be, if it's a 1 or a 9, it has to be at the beginning of the line. So pink cannot be here because we know it goes there, and it would force it to this column, and these two here would point it to there, and that will not work. So this one is yellow, and now pink does have to be down here. It can't go with yellow, so it is there. And now we get the 6, and that has to be with 9 and 3 and 6. And now this is, whoops, a 3 or 9. So yellow is 9 and pink is 1. Like that. There's going to be a 4 in here with a 2 and a 8. 2, 4, 8. So now we take that out. So this is a difference of 5, which means that this is a difference of 6, which has to be to 8. Which puts 4 in the corner. And this will now be a 3 or 7, and it must be 7. This one was 5, good. Now we get a 2 here, and it must be copied, because this is a difference of 0, that line. This was the 7. That is good. So this is a 2, 6 now. I should know this row. 5, 7, 9. And this one must be the 9. So these are 5, 7. And these will be 4, 8. Yellow is on the top here. Yellow could go here though as well. If it did, it would be 9, 8, 7, 6, 5, 4. That would work. I guess it could also work if it was here though. It'd be over there. So that could definitely still be 3, is what I'm getting at. Either way works so far. This one cannot be pink. Neither can this. So that one is. That'll take that pink out of there. It'll put it there. Those two are 1. Which means 2, 3, 4, 5, 6, 7. Which means the 7 has to go on this line somewhere as well. Now, so we have 4 digits known out of 6. A 2 will be in one of those. This cannot be a 7, as it would have to be 6, 6 here. It could be 8 though. Oh no, it can't. Right, so does this have to be a 4? Yeah, 4 is the only number this can be. Nothing else works because of the way, because 5 would either go here or 6 would go up here. So this has to be 4, and it has to count up or else it's going to run out of digits. So it has to go all the way up like that. That'll make that to 8. That'll solve some in the top box as well. A little bit. Oh, this is already known too. That gave us the last yellows, I think. And a 5 there. Is that all the yellow? Yeah. All the pink, yeah. This is a 3 and a 2, so that is known because of that 2 there. That'll sort that top box. That'll put an 8 right there. 7 will go in one of those. 3 will go here. 4 in one of those. These will be a 5 and 6. So that is known as well. That'll do all that work. What's over here? A 3. Two, 3, 4, and 7. 3 goes here. So 3 goes there. Now these will be 4, 7, which also means 4, 7 will be up here. First one because that's all that's left in the row, but I saw this first actually. These both being in the bottom 2 means that it had to be on the top. And this one cannot be 7. What else is in this column? A 3. 3, 4, 7. This one is 4, 7. Can't be a 4. And now this was 3, 4. This the 2 is going to be over here, and the 2 is here. So there must be a 2 in the middle up here, and that is the only cell it can be. And that's going to go with an 8 down here. Up here it's going to go with a 5. And this will be a 3, 8. Neither of those are known yet either. But we do have 8 here and here. So it must go there. And we have all our 2s, yeah. Our 3, not quite. 5. 6 by Sudoku. 7. A 7 is going to be in one of these. And it's in these 2. So it must go here. And that's going to give us quite a bit, I think. What else is with this? 3 of 4. So this row has 3, 4, 7. And we see 3, 4 here. So that one must be a 7. This will be a 3, 4. We see a 3 there. So that works out like that. That'll be a 5. And that'll do it. Hey, that was a nice puzzle there by Olof Helleblad Johnson called Disco Floor. Check it out for yourself. I'll put a link in the description below. And like and subscribe if you enjoy. Thank you so much for watching and have a great day. Bye bye.